We'll continue. So what if we were unlucky? So if we were unlucky, one of our assumptions was violated. So now we had a quite nice case. So there was no issues with normality and homogeneity of variance. And we could have been unlucky. So one of the options you might have heard of is non-parametric tests. And so there are tests which don't make the same assumptions as parametric tests, as tests which use normal distributions. Are you trying to get slides?
No, I'm just showing which shelters.
Okay. Okay. So these type of tests do not assume a normal distribution, but they can be less powerful. And as is again the case, many options exist, and you can read and find others. So I will run you through some standard non-parametric tests, but there are a whole bunch of other tests which I won't cover and which you can read about or find out more about in your own time. Yeah. So there's the RS2 package, and that does lots of the non-parametric tests. And so the T one-way function computes a one-way ANCOVA for the medians, and so homoscedasticity is then not required. So so we'll just look at the medians rather than the means, and it will also take into account that you don't have to have homoscedasticity. So if you have a violation, there'd be one way to resolve it. And if you want your post-hoc tests, you would use the Lincoln command to get post-hoc tests as you would do with QKey ASD to get post-hoc tests. So just to give you an idea, and because this uses bootstrapping, we also tell it to take some large number of bootstraps. So that's the n boot. And again, you might have noticed also when you were doing bootstraps for your assignments that your computer will do lots of number crunching, and it will take some time. It'll be like get a cup of coffee. So, but it's doing hard work, and so it's using its computation power to run lots of tests for you, and then you can evaluate those. And some of you have actually printed all 10,000 tests in their assignments, so or in their exercise. So, but basically, we can ask the computer to do lots of number crunches for us. So this would be the command. So we require the WRS2, and in this case, it's a percentile bootstrap, and it's because this package doesn't do any type of other bootstraps. So percentile just means it's the percentage points which get evaluated. T one way, that's the command which I've just talked to you about. O for openness, group factor, the data, and then we have to tell it how many bootstraps we want. We'll do some number crunching, and then you get this type of output. It will give you the degrees of freedom, and it will give you a p-value. And also in this case, we get the same type of results as with our parametric tests. So in this case, our conclusions will not differ. So again, remember that here we're lucky, and all our assumptions were met, but that might not always be the case. So that's why I'm telling you about non-parametric alternatives. Yeah, and so it also gives you some type of estimate for effect size, if it can. Okay. There's also T1-way BT, so that's another thing. So this function, so sometimes you might not want to use the median, but you want to shave something of the mean, so you have some type of outliers, and that's known as trimmed means. So you can tell to, for example, discard the 1% most extreme cases. That would be, you can read more about trimmed means when you click that link. But sometimes you want to use not medians, but the means, and just shave off, let's see, some extreme cases, and then you would use trimmed means. And so in this case, it's T1-way BT rather than what we had before. And again, you get this type of bootstrap samples and the test statistic, the p-values, and again, similar type of conclusions as we had before. So all good. We can also use a medians test, which is a proper non-parametric way of doing this. So in this case, it doesn't assume homoscedasticity, but you might be asked to just, by your supervisor, run a test on the medians. Then you would do this. If you have many ties, so if you have many ties the same number, then you should not run this test. So if you have something which is sensitive to lots of ties, because they will be, I think, excluded from computation and will lead to problems. So ties means if you have the same number in your data set. This is how you would do it, and here it's very unhandily. It's iter for iterations rather than bootstraps, and because it uses iterations and not bootstraps, and they're different things. That's why it's differentiated. And again, the same type of conclusion, perhaps a lower level of significance, and no effect size measure. But you should know that these type of things exist, and there are alternative ways of doing non-parametric tests. And some of them will have homoscedasticity assumptions still, and some of them won't. And so depending on the power, and you would have to read a lot more about which one is the best possible test you could find. But for your case, that's how you would go about it. And so in this case, the analysis of medians leads to the same conclusion as we would have done with the mean. So it's still significant. Yeah. Perhaps we're not at minus 17, E is minus 17 anymore, or E is minus 7, but still pretty good. So you can read through the WRS2 manual or the Wilcox book to find out more about all these different procedures if you ever need to use them. Another cool thing I want to tell you about is permutation tests. Permutation tests are pretty nice because they're basically based on random shuffles of your data. So it's not the same as bootstrapping, but basically the premise is that if we shuffle your data lots of times and we still get significant effects, then perhaps there was something, well, if your actual data differs from random shuffles, then perhaps there was something in your actual data. That's more or less what a permutation test is. So there is no power issue with this type of thing because it's just using your original data and shuffling them around. So it's quite a neat way, which we can now do with computers, which you wouldn't be able to do before because it takes you so much time to shuffle all the things. But in principle, you could take all the different shuffles which exist for your data. So basically, in Excel, it would be randomizing all your things and do that for every different possible combination which exists, which would be a very large data file. But we can also try and approximate them and just do it a very large number of times without actually having to calculate every single possible combination which exists for your data. Yeah. So permutation tests. So shuffles are not the same as bootstraps; they're something else. So you're aware. And some assumptions do still apply. So if you violated non-independence, then this is not going to resolve it. But the other things is that it just uses will just work in terms of shuffling your data. Again, you can read more here, and I could have an entire lecture just on permutation tests, but they're pretty neat. So we use the coin package for that, and then the code is independence tests, and then O, again, same type of structure, data is data no miss, and then it will do an asymptotic general independence test, and so basically we'll do all sorts of shuffles, and then it will show you whether your data is different under chance compared to your actual predictions. That's quite nice. And so in this case, again, it doesn't alter our conclusion. We again have the same conclusion. If you wanted to do a sample write-up for a permutation test, it would be something like this. A permutation test via the coin package showed that there are a significant difference between the three groups in openness to experience. And you report this max T type of value and a p-value. Yeah? So again, some things the APA knows, and so everybody knows that an ANCOVA comes with an F value, but nobody knows how permutation tests work. So this would be a sample way of how you do it. So the core idea is that people are able to replicate what you did in your analyses. And so usually that means saying how you did it. You can also get post-hoc tests. They're currently unavailable via coin, but there are ways to get them if you really want post-hoc tests also for your permutation tests. Again, I will go into detail because that's super advanced stats. ANCOVA, have you heard of ANCOVA? The difference is a C, so it's a covariate. So often we want to control for something. So suppose you're doing a test on a new weight loss drug, and you want to control for participants' start weight at the beginning of the trial to see how much they actually lost at the end. So you could then analyze participants' weight at the end of the trial while parceling out their starting weight, and that's the C bit. So that's the covariate. So you would have different experimental treatments in terms of the dose of the drug people which they get, which is the ANCOVA part, and the C bit is the covariate part where you partial out the type of effect of their own starting weight. Does everybody understand sort of the premise of that? This would be an ANCOVA scenario, but beware, there's some arguments going on in literature, and I can't rehearse all of them, but you can have all sorts of fallacies. So, for example, if people start at very high or very low, they can only move up one way or the other way. And so there are some issues perhaps with ANCOVA where there might be different solutions for the same type of problem. But your supervisor might ask you to do an ANCOVA, so that's why you should know about it. You should also be aware of Lord's paradox, which is something very, very technical, but it's basically if you have one researcher which uses an ANCOVA approach, and the other a researcher in this scenario would have calculated the difference score between post-weight and pre-weight. So he would have taken the post-weight, subtracted the pre-weight, and done an independent samples t-test on that. Now, logic would dictate that you would get roughly the same type of conclusion, but that's not the case. So you will get different conclusions depending on whether you do a different score or whether you've done the ANCOVA. And there's mathematics behind it why that's the case. And in this case, there is no optimal solution. The techniques make different assumptions as to how the relationship is between weight loss and the control. Again, you should just be aware that if you do an independent samples t-test on a different score, you might get something else than when you do an ANCOVA. So if your supervisor tells you to do one or the other, have a think beforehand and be aware that you might not get the same result if you do an independent samples t-test on different scores compared to an ANCOVA. Now, the important bit, why I also told you about different ways of doing ANCOVA, is that are sensitive to order effects. So the order in which you put things in this equation matters most of the time. And so just to show you, so LM ANCOVA, so this is LM, and in this case I've put in E for extraversion, which is the covariate for which I would want to control in this case. This is not the best possible example. Ideally I would have used something like weight loss where it makes more sense, but suppose that we want to find out whether the openness to experience effect exists after parceling out the extraversion effect. That's how we would do it. And then we add our factorial variable, the different groups which people offer, and again, data is data no miss. We get this type of results, so E first and then group fact, but this is not the same as this. Group fact first and then E. Yeah? And that's because there's different sums of scores and different ways in which you partition up the variance in this type of command. So in this case, the difference is not huge, but for example, 1.209 times e to the minus 9 versus 1.894 times e minus 0.8. They're not the same values. Yeah, and that's you have order effect, so it matters which one you put in first. That's important to know. And I'll tell you more about types of errors later, but you should know for now that there's type 1, type 2, and type 3 errors. Most of the time you will have used type 3 errors in SPSS, but R by default uses type 1 errors, where the order matters in which you put in things. And there's good reasons for doing that, and I won't bore you with all the details, but there's good reasons why that's the default in R. So for now, you should be aware that the type of order matters. You can read more about those type of results. And SPSS uses type 3. So let's aim to emulate. So let's aim to get as close to SPSS by using those type 3 errors, because that's usually what your supervisors might want as well. Okay. So there might be cases where that's not optimal. So in order to get the type 3 errors, we go to the car package. And we can then use the LM command. And we also need compute.es, which is to compute effect sizes and also to compute some of the contrast for us. So now it becomes slightly more complicated. So LM O group fact plus E, and then the contrasts, and we have to give it a list of the contrasts we want, and that's how we do that. And then we tell it explicitly to use type 3 errors. So we use ANCOVA, and then type 3. So that it knows it has to use type 3 errors. So you can also change that to type 1 or type 2. And again, you can read more about those differences in errors, but I'll also talk to you about them when we talk about moderation effects and 2x2 designs. For now, all you need to know is that they exist, that order effects matter if you don't do it, and that's why we use type 3 errors. And so in this case, it will actually print you that it's type 3 type of tests, and then it will print you those type 3 errors. Everybody sort of with me? To do the post-hoc tests, we need another package, because now we've messed about with the orders. So we use the multcomp package, and then we do this type of command. Actually, perhaps you should have used an arrow rather than is, but it's the same type of thing. So that will have been, I'm not sure I went too fast, ANCOVA. This type of code, this is to tell it it's Tukey, and linfact is, I think, short for linear factorial, because you can also have quadratic contrasts and all sorts of other contrasts. And these are the commands you need in order to get this post-hoc tests going for the type 3 type of tests. Then we do summary, and then it will make some type of nice formats. And these are this sort of looks similar to what we had before, right? So it's you have probabilities at the end, and here it's PR larger than T, and those are significant. So the difference after parceling out extroversion, we still find a significant difference between Asian Americans and European Americans, and between Asian Americans and Asian internationals. Yeah. And again, you can follow up, and you can see if you can then use Broom and Tidy to get a nice little data frame going and export it. Or you can see if some of the things will directly be ported into APA tables, but some of them won't. So sample write-up. So writing a report, a one-way ANCOVA was conducted to compare openness to openness to experience across groups. Whilst controlling for extroversion, there was a significant effect of cultural group. Yeah, that was a F test. So if we go back, oh, did I miss it? Where did I? Yeah, so that's this F test. Yeah. So it should be 21.23. See if I put it in correctly. Yeah. Oh, too fast. Sorry. 21.23. That's that value. Significance. And in addition, the effect, sometimes people also then talk about covariate. Sometimes they don't, because it's just the thing you want to control for, like starting weight. It's not that interesting. Starting weight will be significant with end weight. So, but in this case, you would write extroversion was significant, P is 0.01, and then you would describe post-hoc differences. And you would further explore perhaps how extroversion is associated with openness. So you would make a plot perhaps. We'll go on for 1 or 2 more minutes. Oh, that clock is actually 11 already. No? Or is it, that clock is, yeah. So I'll stop here. I'll put the remainder, which is less than last time, I think. So it's I'll put the remainder on video. So I'll cover MANOVA, and then I expect you to work through the exercise at the end again and try and upload it. And again, if you have any questions, post them in the discussion board. Try to be specific as to what you're into, and try to be also try to make new threads if you have a new topic, and try to highlight what you've done to find the solution to the answer, and try to because that's handy for me also to find out where you're struggling with.
Thomas, what did you put the solution on as well for the test from last week?
If you've submitted it, then I've sent you a link. Okay. I think then something might have gone wrong, but the way it usually works is if people submit something, it will be my test center, and then I'll send you a link with the correct reply. Send me another email if you still can't find it in Blackboard. But I think it's some of you did receive that, right?
I like messaged on the discussion board because I hadn't, and then once you saw it, you said it worked then.
Okay. So, but normally if I use if you submit it as a test.
I got the first one.
What?
That was the first one I submitted that, and I got the solution for the second one.
Could it be possible that you didn't didn't send in the final version, because that's the other thing. If you don't send in the final version, so if you store the temporary version, because I don't think I might have actually seen yours, and then you would have not gotten a reply.
I'll double check that.
So double check, and if otherwise send me an email say I've submitted it. Can I have a solution, please? And then you just attach it by email if it doesn't work by it. But normally by the portal, you should be able to get feedback and then a link in Blackboard. Okay. Best of luck, and see you all next week.
Yes. You know what the outcomes and the tests on R? It's obviously a bit more complicated than the ones on SPSS. Is there any kind of like cheat sheet or anything like that? show you what to look for.
Sorry,
Just
what do
try.
you mean in terms of?
So, like for example, look, one we did there, it showed us the